Today's lesson, we'll be talking about section 6.4, where we are discussing inverse, trigonometric functions, and right triangles. So here, I have drawn a coordinate plane on the unit circle, and I've described the angle of 30 degrees, where your point for x and y is square root of 3 over 2, comma 1/2. Okay? Now the x value represents the cosine of 30 degrees, and then the y value represents sine of 30 degrees. Okay? Now, usually if you're asked to find cosine or sine of this angle, you would tell us a ratio from the point that it lands on in the unit circle. So if I said cosine of 30, you would repeat back that it's square root of 3 over 2. If you said sine of 30, it would be 1/2. Okay? Now, if we did it the opposite way, so an inverse trig function, and I asked for what's the inverse sine of 1/2, then that means that you would use that 1/2 to go to an angle and tell me what angle represents or has that ratio for sine, the y value, for its terminal point. Okay, so you can also go backwards. Now the thing is, for that to be keyword function, it needs to have some properties or restrictions, because if, let's say, I do sine of, or I say the inverse sine of 1/2, 30 is not the only angle measurement that gives me a sine of 1/2, or 1/2 for sine. If I go over here to this other side, this point is negative square root of 3 over 2, comma 1/2 for 150 degrees. So both of these values, or terminal points, have a y value of 1/2. So there's two answers. So for it to be a function, 1x cannot go to 2y's. So for it to be one-to-one function kind of thing going on, we need to restrict the domain for each of these so that we can get or keep our functionality going on. So for sine and for tangent, we restrict our trig functions to the first quadrant and the fourth quadrant. Okay? So that means, let me write this down here, for sine, we go from the domain values, so they're ratios. You can go from -1 to +1. The range would be all the way from this point all the way around your circle up to the top. So that means that I can go from -pi over 2, which is because I'm going in a negative direction to get here. Okay? We can't go around the circle to get to this point, because then I'd be going through a restricted area, which is second and the third quadrants. So I need to go in a negative direction, so that's why I have -pi over 2 instead of 3pi over 2. And then I can go all the way to pi over 2. Okay? Cosine, alright, let's do tangent while we're here. Now tangent's the same way, except the domain, because you're dividing y over x, those ratios are infinite. So it's actually all reals for the domain, so you can have any value for tangent, positive or negative, but the only values you're going to get for the range are in between -pi over 2 and pi over 2, kind of like sine, except we do not include -pi over 2 and pi over 2, because at those points your y value is 1 or -1 and your x value is 0. So when you divide by 0, it's undefined at those points, so we don't include those values. And then cosine is different, because cosine has different values because it's talking about the x. Sine is talking about y, so we want to be able to go up We want to be able to go up and down. Cosine's talking about x, so I want to be able to go right and left. So then I'm going to restrict cosine to the second and to the first. So that means it would go from -1 to +1. Same thing. Okay, so from pi it's -1 and all the way to 0 it's 1. And then that means that I can go from 0 to pi. So those would be the domains and ranges for your unit circle to find inverse trig functions. So let's apply this. If I want to evaluate the following, I want to find sine of square root of 3 over 2. Okay, so you're in the first or the second, or sorry, it's first or the fourth. Sine is positive in the first, and there's only one spot that it's square root of 3 over 2 since it's on the unit circle. So I would say that this is 60 degrees. My answer. Okay. For tangent, a little harder because you have to take the y value divided by the x value. So since you're restricted to the first and the fourth, like sine, then here, to get a -1, it has to be the same thing over the same thing, right? So at pi over 4, if you think about it, it's the square root of 2 over square, or comma square root of 2 over 2. So then that would give you 1, but we want a -1. So in the fourth, your y value is negative. So then the division of this value over that value would give me a -1. So then that would be -pi over 4. Okay? Now another thing we'll need to be able to do for like word problems is to be able to use our calculator. So if you take out your calculator, if I want to use the inverse cosine, next to the trig functions on your calculator there should be buttons that above it or next to it somehow say cosine or sine or tangent of negative to the negative first power. So you need to press the second button and those buttons, and then plug in the value that they want you to evaluate, and then you press enter. So for the inverse cosine of -0.71, I would get 2.36, and that would be my answer. There, that's going to be an answer in radians, because we don't really do degrees with this. And then tangent of 2 gives me value 1.107, and that, or you could write 1.11 if you'd like. Okay, so then that's how we do those. Example 3 wants is a word problem. So a 40-foot ladder leans against the building. If the base of the ladder is 6 feet from the building, what is the angle formed by the ladder and the building? So here I've drawn my picture of what they're describing. I want to find x, so I need to use my adjacent, opposite, and hypotenuse thoughts here to find x. So since I have the opposite side and it looks like I have the hypotenuse, I would want to use sine. So sine of x equals opposite, so 6 over 40. Now here I can't really just find, or this is not on the unit circle or anything to help me figure out what this angle is, so I need to use the inverse sine value. Now I can reduce a little bit just to make this easier, so 6 over 40 would be the same thing as 3 over 20. So the inverse sine of 3/20 in my calculator, and make sure your calculator's in degrees here, that gives me an angle measurement of 8.63 degrees. So therefore that would be my answer. And that would be it. Moving on. Now here, this one's a little bit trickier. So here they're doing compositions of using your inverses. Okay, so just like any other composition, you would do what's on the inside first, and then work your way on towards the outside till you evaluate all trig functions. So here it says sine or inverse sine of 3/5 on the inside, and you want to take the cosine of that value. So 3/5 is not on the unit circle, but I don't need a calculator for this. So let's write or draw a reference triangle to help us figure this out. So if I say that inverse sine of -1 is 3/5, that is a ratio of something that may be on the unit circle. Okay. Now sine is restricted to the first and the fourth quadrants, and the ratio you're given is positive, so that means the triangle that you would draw would be in the first quadrant, because that's where sine is positive. If it was a -3/5, we would draw a triangle in the fourth quadrant. So opposite would be the 3, and then hypotenuse would be the 5, because that's how those ratios work for sine. Just like if it was cosine, it would be adjacent over hypotenuse. So I'd write the 3 along the x-axis instead of the side that's going upward for the y. So now for this triangle, before I can find cosine, I need to find the rest of my triangle. I need to find the other side. So using Pythagorean Theorem, okay, so 3 squared is 9, 5 squared is 25. I subtract both sides by 9. I square root. Because I'm talking about something in the first quadrant, x is positive as well. So then that means that my value for x should be 4. And so remember that I'm talking about some angle. So if I was doing a problem before where I said the inverse sine of square root of 3/2, your answer would be an angle measurement. So here, this doesn't change. So the inverse sine of 3/5 is an angle of theta, or some variable that you choose. But we really don't know theta, but we don't really care because we've already drawn the picture for theta. And so the cosine is just going to be the adjacent side over the hypotenuse. So for this angle, the adjacent side is 4 and the hypotenuse is 5. So basically, this step that we drew is not necessary to how to do this, because I don't even have an angle, so I don't have to write it. So once you write your reference angle, that's like finding the inverse of 3/5 for sine. And then once you have your triangle, you can move on to finding the trig function for the value on the outside, the trig function on the outside, to help you figure out the answer. So in this case, it would be 4/5. Okay? Have fun.